It's my pleasure to present to you Pasha Finkelshteyn. He is basically a regular speaker here in Bulgaria. He was here, yeah, he was here a few months ago at our first meetup organized by the Bulgarian Juke. So it's my pleasure to say hi, and
Hi.
the stage is yours.
Thank you so much. We probably should wait for a couple of minutes. Then we have a time for a quick question. Who is familiar with Dockerfiles syntax here? Oh, it's almost all of you. This is so cool because in some audiences I ask this and nobody, like they do not know what I'm talking about. So they come to this talk about Dockerfiles and all this stuff, and I have to explain everything from ground up. Thank you for saving my time and your lives. Shall we start? Well, I still see some people coming. Okay, I can ask another quick question. Who uses Spring Framework here? Okay. Who uses Spring Boot? Okay. Who uses Spring Boot 3? Who uses Spring Boot 2? Why? Like, you don't have a choice, right? I mean, you could switch to newer Java and newer Spring and have all the benefits of better performance and so on, you know, right? Okay, everyone is here, we can start. I suppose you see my face, but this is how it looks when there is a good photograph and nice Photoshop skills and so on. And I'm obviously Pasha Finkelshteyn. I work as a developer advocate at Bellsoft. And I'm in JVM languages for a long, long time. It's written here, it's 10 years in JVM. It's actually 15. I'm just too lazy to update my slides. It's mostly Kotlin and Java, especially with Spring. But I actually used Clojure, Ceylon, what's it, Scala, sure, all of them, even esoteric ones. Who heard about Ceylon language here? One person, two people. Yeah, like that's what I mentioned. Yes, and obviously most part of my career I use Spring Framework because, well, it's just the most popular solution. You can find me, follow me on Twitter, Mastodon, Blue Sky, whatever. I have to say a couple of words about us, like about my company. I work for Bellsoft, as I already said, and we are a vendor of Liberica JDK. It's free, it's open source, you can go and download it at our site. On Docker, we have base images on Docker Hub, and actually we have quite a set of unique features. For example, we have a lot of supported processor architectures, or we have a lot of enabled garbage collectors by default. We are the initial authors of ARM32 support in OpenJDK when it still was a thing. It was the base of our business, but then it changed slightly. And we have our own Linux based off Alpine Linux. It's slightly more secure, it's faster for Java, and we have glibc support. If you know what this you know, if not, well, I mean, we know our stuff, right? And we are officially recommended by Spring, and this is why I'm talking about Spring today. Like, you should know. But let's get back to the topic of our talk. Ultimate Spring image. What is ultimate? I don't know, actually, because what ultimate is very broad. There are a lot of meanings. Probably it's smallest one. Probably it's an image with the fastest startup. Maybe it's something in between. It depends. Ultimate for you is defined by goals of your business. If you're fine with what you have right now, probably you don't need to optimize something. Or probably you'll find something interesting during this talk which you would be able to improve. And in this talk, we'll look at all of them, at all of the spectrum, from the fastest startup to different other trade-offs. But first, let's look at the most awful Docker image of the Spring application you can probably create. You will use something as your base, like JDK or something. You will copy your application to your Docker image. You will just build it inside the Docker image, and you will put entry point java-jar, our jar file. Why is it awful? Who knows why it is awful? Okay, let's talk a little bit. First, each directive in Dockerfile creates a layer of an image. So when we copy our application to an image, it becomes bigger. When we do a build, when we perform a build, it also becomes bigger. And all the layers are immutable, even though some layers are zero-sized. So for example, even though I wanted this image to be almost empty, from bash, copy my application inside Docker, and then delete the whole application and do nothing else. I would like it to be of like 8 megabytes of size, which is the default size of the base image, but it won't be so. It will be very, very different. It will have the whole image in it, the whole application in it, even though we won't be able to see it. And yeah, the same will happen to our application. So here we copy the whole application. Here we have our application built. And as you can imagine, to build an application, we actually download a lot of dependencies. We have a lot of binary caches in Gradle. We have a lot of things, and they all will stay inside our Gradle image. And then, yes, this entry point waits nothing. If we look inside this image, I'm using a software called Lazy Docker here. So it is like 7.5 megabytes of shell, then a bunch of empty layers with such just a meta information. Then our JDK weighs 98 megabytes, point something. Then we have our application. It weighs 67 point something megabytes. Who knows why? Why our application is so heavy? One person? Okay, 2 people. It is so heavy because we do not have Docker ignore file. So we build application in place, and now we are copying the whole application inside Docker. And then we build it. And when we build it, it's 500 megabytes more because dependencies and stuff, including development time dependencies like JUnit and so on, JUnit Vintage, or whatever we use. And then we have our empty entry point. And it means that essentially on every rebuild of our application, 580 megabytes of these applications are being changed, which is a lot, at least in my opinion. Why should we care at all? Well, because building image is not enough. We are distributing this image. Distributing the image means pushing it somewhere, for example, into your Artifactory, right? And then in your production, Kubernetes or whatever you run, you pull it from this Artifactory or container registry. And it means you will have to push and pull 580 megabytes of data, which is almost not changed. So let's try to optimize it a little bit. So this is what we had. But let's replace it with a very simple thing. We can build the application locally. We can just copy jar file and then put entry point java-jar myapplication.jar. Is it good? Who thinks that it's a good solution? Oh, you know me, right? Mm-hmm. Okay. So it is actually significantly better. For example, it used to be 67 megabytes for application and 512 megabytes for dependencies and build. And now it's just 58 megabytes for the whole application, which means with like removing one line of code and swapping another line of code, we saved like 500 plus megabytes. And from push-pull point of view, it is significantly better, but it is not a clean build now. And not clean builds are like they're bad. They're bad because if something is building correctly on our machine, it doesn't mean that it can be built correctly on some other machine. What if the environment changes? What if the environment affects the whole thing, the whole build? And at this point, entering the build stages of Docker. Who knows about build stages? Some of you. Okay, this is good for you. Let's explain to others. Build stages are a situation when you have multiple definition of different Docker images inside Dockerfiles. We'll look at the example a little bit later. They allow you to perform clean builds. For example, in one image you can perform build, and in another image you can just copy a jar file from this build to your new image. They allow us optimal packaging, at which we'll look a little bit later. And they allow us to use different base images. Why is it important? Because we actually do not want to run JDK in our production usually. In production, GRE is enough. We do not need JavaC, we don't need compilers, we don't need any specific stuff. We need GFR, we need Java to run our jar file, and that's essentially all. Here's a simple example of staged build. So first stage, we'll call it how? Builder. We copy our application into it, and then we build it inside one image. And then we create a new stage, which is called runner in our case. And then we copy our jar file from builder to a new image. And this is almost the same as what we did the last time, except it's not environment dependent anymore. And this is good. And if we will look at the final result, it is exactly the same. We have, 58 megabytes of application. Is just not environment depending. And that's kind of all. Well, or not. Depends. Let's look at this. What are these 59 megabytes? Where do we take them from? Because we still have to pull and push them every time. Maybe, just maybe, there is a way to optimize it. Who knows how to optimize it? Oh, this is an actually useful part of the presentation. Hopefully you will learn something new here. So, the first stage remains the same. We have builder that just builds our application with Gradle. Then we create a new stage called optimizer, because our imagination is infinite and our names are beautiful. You can see that it is not a layer built on top of JDK, it's built on top of GRE, because already at this stage we do not need to compile anything, so GRE is fine. We copy our application from builder, from our previous image, into our image, and then we run this specific command. java-d jar mode equals tools -jar application.jar extract --layers --launcher. This thing is actually magical. It creates a layers for us, which we will then use in our runner layer. There are 4 layers. One of them is called dependencies. Obviously, our dependencies usually do not change, right? Like me, I mean, we do not update our dependencies every day, and we do multiple commits a day usually. Sometimes we do not update dependencies for months, because if it ain't broken, don't fix it, right? Then the next layer is Spring Boot Loader. It's just internal Spring machinery that will allow us to launch the application. Then snapshot dependencies. How many of you have snapshot dependencies in their applications? None. That's what I expected. That's what I usually see. But there are rare cases when you can actually have a snapshot dependency in your application. Say you found a critical security bug in your application and you reported it, and the developer was very fast and they fixed it in the library, but they cannot release it right now. They need to create a snapshot release, and you will be able to depend on this snapshot release, test it, report back. So it's kind of feedback loop until we are ready and until we are sure that our library is actually working correctly. In this case, you might actually need snapshot dependencies. And then we have the layer with our actual application. We copy all these layers one by one into our application. And this way, we ensure that the more frequently a layer can be updated, the more probability that it will be actually updated and pushed and pulled and so on. I suppose that our code might change faster than snapshot dependencies of our applications. And then we slightly change how we launch our application. We use Java and then this magical class from Spring Launcher or Spring Framework, bootloader launch, jar launcher. I need to say a couple of words about this command which you see, which you saw, jar mode equals tools dash jar my application jar. It actually has two subcommands. One of them is extract, and one of them is list layers. Extract does almost the same thing with slight tuning. List layers is interesting. Imagine you're not satisfied with how layers work out of the box, and you want to customize the behavior, which is a perfectly valid thing to do. List layers will just list you potential content of layers. And knowing all the dependencies and so on, you can do your own stuff on these dependencies, put them into our other directories. For example, you know that one of these dependencies is your internal company's library, and it's updated more frequently than other libraries. You probably want to put it on a separate layer after usual dependencies, because other dependencies won't be updated as frequent as this. Now, let's look into the structure of the layers and how it looks. Essentially, it's an application. Inside it, we have our application with all our settings and a lot of classes generated by Spring AUT, ahead of time compilation, and then obviously all my classes of my application themselves. And these two files, class path IDX and layers IDX, which I think names are kind of self-describing, right? Then we have all the meta information with, for example, information for native image to work. Then SBOM, who knows SBOMs? SBOMs are very important, especially for security-related people, because SBOMs, they tell us with which versions of libraries and with which versions of tools and with which version of Java the application was created. The next time you will need to pass your security audit, they don't only need to read your whole source code, they also need to be sure that there is no supply chain attack, that you didn't use vulnerable tool which could compromise their build. It is actually a thing. Then we have obviously all our dependencies, empty snapshot dependencies, as well as you, I don't have any snapshot dependencies, and Spring bootloader with a lot of magic. And in total, it's 212 directories with God knows how many files, which are laid out in a very smart system that allows us to save a lot of space in our image. Let's look at it, by the way. So, what are we interested in? Our dependencies weigh 57.7 megabytes. Our launcher, Spring Launcher, is like 380 kilobytes, and our application in compiled way is 3 megabytes. And together it's like 61 megabytes. And those of you who are very, very serious about what I'm talking about already noticed that 61 is obviously bigger than 58.8, which we had before when it was just one jar file. Pasha, we wanted to optimize how much we push and pull, right? But what we're actually optimizing? We're actually optimizing not the size of the image. It doesn't make a huge sense to optimize the size of the image itself. We need to optimize how much data we will trip from our server and to our server every time. And now it's essentially 3 megabytes on every push and pull, which is significantly better than 60 or 58 megabytes, roughly 20 times better. And what we just described is essentially how build-softs and native build packs works. Build pack is a, who knows build packs? Oh, I'm surprised. Some people know build packs. Cool. Let's explain to other ones. Build pack is a very nifty command that gives us this one common pack. We call it with some arguments like build, like Docker. Then we give a name of what we are building. Then we are telling which builder we are using, and I'm obviously using build-soft builders because they are better, but you're free to use the ones you like more. Then we give a path to our application, and then we can add some environment variables, for example, which Java version is more interesting for us. And you don't need to write a Dockerfile. This is the beauty of the stuff. Like, this is the result of work of our build pack. It's obviously then JRE, then application dependencies, then our application, then Spring Boot Launcher, and that's all that's important. So, if you are fine with this layout, if the only thing you wanted to optimize is push and pull size, you probably don't even need to write any Docker file at all. You're probably perfectly fine with just using build packs, because they do what we just spent, I don't know, 10 minutes on in one command without any programming whatsoever. Here is some info about build packs. They are like S2I images. They were introduced by Cloud Foundry, which is the team which works with Spring, but who cares? They build better than like default build, where we just copy jar file and do not create any layers or anything like that. And they are Spring aware, which is very important, because they know that Spring supports layers, and it means they can call this layering thing and reuse it, as we just saw in the lazy Docker tool. Is this all? Because we have optimized push and pull size? Well, hopefully it's not. Because as I already said, optimization is multidimensional. And we have optimized push and pull size, but we want to optimize startup time of our application. Who has a Spring application which starts up for like 1 minute? 5 minutes? Okay, no one. In the previous audience, I saw people who has an application whose application starts up for 20 minutes. Imagine that. Even 1 minute is long for me. I'm a very impatient person. They say that I have ADHD, so when it starts up for 1 minute, I'm already on Facebook, Twitter, whatever, writing random pieces of code because too long to wait. When it starts up for 5 seconds, I can wait really. So Spring Pet Clinic is my sized project. And there are multiple ways to optimize startup time. Today, I will talk about CDS, coordinated restored checkpoint, and native image. If you want to hear more about that, we will have a huge talk on them on Spring I/O in like a week or so. I don't remember. The whole talk only about startup time optimization, and almost nothing about Docker at all. Let's start with CDS. CDS was introduced in Java 5. Who heard about CDS during Java 5 times? Yeah, that's what I thought. The idea was very simple. Since Java 5 was long ago, and they used to launch many JVMs on one machine, right? So they were like, since we are launching one Java on one machine many times, let's optimize this part. And every time, and when we launch the first JVM, it will create some smart archive of classes, which we will use on consequent startups. And yeah, how can it help us? Because we do not do it anymore, right? Well, it doesn't. But in Java 10, application class data sharing was introduced. This is a much more interesting thing. Now we can not only save data for our JVM, we can save data for our application too. And we don't need much to use it. We'll look at it a little bit later because, well, in Java 13, they implemented JEP 350, which allows us to automatically save classes on application exit, which will be very useful in a minute. We need to add only a couple of arguments to our JVM. First is archive classes at exit, which says where we want to save our archive of all the classes our application created. And -d Spring context exit on a refresh. Who knows this key? No one. One person. Sorry. It is an amazing thing. Actually, when you add this key, Spring loads on non-lazy beans and then shuts down the application altogether. So it's like a training run which shows Java which classes should be loaded in the first case, in the first times. And it, since we have the first argument, it automatically creates the archive that we can reuse in our Docker. But we should use the same GTK and we should use the same program arguments, which is kind of okay, I guess. And it becomes even better if we use Spring AOT enable true, because if we enable Spring AOT, it will dump a lot of things it usually does at startup time, in build time, and we will have a lot of classes, we will have all the tree of our dependencies rendered in like a ready-made structure. How we use it? There is a small Docker file on the screen. I'll try to be gentle. So, first, we need to replace our library runtime container JRE slim muscle with, seriously, JRE CDS slim muscle. Your JVM should contain CDS in it. This is why we have multiple builds. Obviously, if JRE contains CDS, it's slightly bigger, but you can use what it has in it. Then we just copy all our layers as we did before. But we also add this one run, which looks cumbersome, but let's try to dig into it. It's Java with Spring AOT enabled, which archives classes at exit to application.jsa, which will exit on refresh, which means we'll load all non-lazy beans and will exit. And it will use jar launcher to launch application. And our entry point will also slightly change, like this. We will add Spring AOT enable equals true, and we will again say what is our shared archive file. And this way, our application, hopefully, will start up faster. What do I have here? How is it different? Don't look into it. Not important. Really, I mean, I put it there accidentally. But it has a cost. Our application starts up faster, like 20 or 30% faster, depending on the application. But we have to save a huge archive inside our Docker file. It's 81 megabytes for relatively small application. And here you should understand there is no such thing as a free cheese. We should trade our trade-offs, that should decide what our trade-off will be. Do we want it small or do we want it fast? It's a business decision, it's not a technical decision. If you don't need it to start out faster, stick to the previous solution. If you need to start up faster, then you are probably fine with this. We are trading some space for some performance. I'm writing here 50-60%. It's like an extreme. In real application, I wouldn't expect to see that, but sometimes you can. You can push it further with a project called Crack. Project Crack stands for Coordinated Restore at Checkpoint. The whole idea of the project is, let's take the whole memory of the whole Java application and dump it onto a hard drive. And the next time, when we will need to launch our application, we won't spin up any JVM, we won't read any classes, we won't compile anything. We'll just restore the memory snapshot from hard drive to our memory. And this is like crazy fast. And in perfect world, it should be something like this. We should have library runtime container with JRE and crack slim, and we should be able to just add a couple of arguments to our Spring application with Spring context checkpoint on refresh, and crack checkpoint to location of our crack snapshot. And then we'll do something like this. Copy our application, copy our checkpoint, and launch the application. But in reality, this is what we would see if we would try to do it. This Docker image won't build. It will say that, what does it say? Native checkpoint failed. Because crack is hard. Crack is hard, and you will actually need to make your hands dirty. First, we will need to add this magic declaration in our Dockerfile, syntax equals docker/Dockerfile 1 labs, and your security team will start asking questions. Why do we use 1 labs syntax of what is this thing? It's not an over. It's not everything. Now we have this line. We'll need to change it. We'll need to add security in secure. Again, Spring team. Yeah, security team will probably have questions. It's not enough, because every time when we do checkpoint, our application fails. Well, it not fails. It exits abnormally. It's not with exit code 0. So we'll have to add this double pipe true, like Docker, I'm sure everything was fine. You shouldn't care about it. That's not all. Now, we'll need to create a new builder called, with allow insecure entitlement, security, and secure. We can call it accordingly, insecure builder. Just, we already have many questions from the security team. Why would we care? Then we can use it by default, by the way, if you want, because it's already bad, really bad. And now the easy part is to build the image. It will be Docker buildx build. Buildx is the thing that will replace usual Docker build in near future. Allow security and secure. Well, and then it's boring. It's just a build, and then we can just use it. Also, to run this image, we'll need to do something special. We'll need to run it with double-dash privileged, which means essentially your container can do anything on the host machine. Again, it's already a bad situation, but it works. If you look into this, these are actually bad results. I usually have my application starting up with crack in 20 milliseconds. Luckily, sorry, I'm jumping. Is it okay? Is it a good solution? If it works, it's enough for you, then yes. If you want something that will be actually allowed inside your company, then probably no. We have a way around. It just won't be simple, sorry, but it will be more secure, I promise. First, you need to build a jar file any way you want. I don't know, locally in Docker, you can do it. You obviously can do it in Docker. Then create a new image that will run jar with crack arguments in entry point. You don't need any kind of obscure stuff here. No the syntax labs, no security insecure, no nothing. Then you will need to run this container with 2 capabilities, only 2. cap CSP trace and cap checkpoint restore. And you can guess, cap CSP trace is needed because Java needs to know which processes were launched from it and how it was launched. And checkpoint restore is kind of trivial, right? It needs to be able to checkpoint. The container will run and stop, and then when it's stopped, we can call this command docker commit container ID and put a new tag in there, like how we want it to be called. And this is all. After that, you don't need any privileged access, nothing. But it obviously has its pros and cons. It doesn't require any arcane magic. It's a pro. It works very predictably. You just need a more complex pipeline which will be organization specific, which is a cone. I cannot give you a ready-made recipe which will work for your organization with your CI/CD process. It obviously requires more steps, because before that, everything we had was just Docker build. It doesn't depend on unstable features, and it doesn't require privileged containers, which is a huge pro. I mean, by default, they're disabled in Kubernetes. And now we kind of have all flavors of ultimate Docker images. Fast ones, oh, by the way, I lost the slide, but for Springpad Clinic, the size of crack snapshot is roughly 500 megabytes. It is big. Java takes a lot of memory, sorry. What I forgot to mention is native image. Native image is amazing technology which will give you actually fast startup time. Slower than crack, faster than CDS. It is a pain to use sometimes. Sometimes your application is fundamentally incompatible with native images. Sometimes it just takes 20 minutes to build it. So it's up to you. If you can make your application, also developer experience is imperfect, let's put it this way, because you are running in production something you do not run on your developer machine, and it means somehow it's a different experience. We can't be really sure that it's the same thing. Like Oracle promises us, and we trust them. But who knows? I mean, tomorrow things can change. Quick summary here. First, please use layers for faster deployments. It's like a no-brainer. The first thing you do when you are building the next Docker file for your Spring application, you do it layered. You can just copy-paste my Docker file and reuse it. Or you can use build packs. Second, if you need slightly better startup time, think about using CDS, AppCDS. If you are on Java 24, there is a new iteration on AppCDS called AUT Cache, which is even better, and you can use it. Third, if you need lightning fast startup times, for whatever reasons, you are a huge insurance company, for example, and you have 1,000 of servers, and you want to update all the servers very fast with gradual rollout, you probably want to opt in with crack. Fourth, if you can build your application with native image, you don't want to go with all the trouble with crack, use native image. It will give you very, very good startup times, especially the commercial edition. And this is pretty much all. You can find here, you can subscribe to Bellsoft blog. We write all this stuff there and a lot of different technical stuff. And you can subscribe to me too. Thank you so much.